For my question, I have let f be the function given by f of x equals the natural log of x over x for all x is greater than 0. The derivative of f is given by the derivative of f of x equals 1 minus the natural log of x over x squared. So for A, it says, write an equation for the line tangent to the graph of f at x equals e squared. So since we're given the x value of e squared, we need to find the y value. So we plug in e squared into the equation. F of e squared equals the natural log of e squared over e squared. So we bring the 2 over here, so it will equal 2 times the natural log of e over e squared. The natural log of e is 1, so it will be 2 over e squared, and that is the y value. Now we need to find the slope. So the slope, we'll have to plug in e squared into the derivative. So the derivative of e squared, the derivative of f of e squared equals 1 minus the natural log of e squared over e squared squared, which will equal 1 minus 2 over e to the 4th, which equals negative 1 over e to the 4th, and that's our slope. Now we plug in the values into the equation of a line tangent to the graph of f, which will be y equals, y minus y1 equals m, which is slope, x minus x1. So if we plug in the values, it will equal y minus 2 over e squared equals negative 1 over e 4 to the 4 times x minus e squared. To simplify, it will be y equals negative 1 over e to the 4th x minus e squared plus 2 over e squared. And that would be the final equation. Okay, now for B. It says, find the x-coordinate of the critical point of f. Determine whether this point is a relative minimum, a relative maximum, or neither for the function of f. Justify your answer. So, to find the critical point, we set the derivative equal to 0. So it would be 1 minus the natural log of x over x squared is equal to 0. So the bottom x squared, if we set this equal to 0, x will equal 0, which does not satisfy the interval that we have of x is greater than 0. So this does not exist. Now if we put the top part equal to 0, 1 minus the natural log of x equals 0, then it will be negative the natural log of x equals negative 1, the natural log of x equals 1. So e to the 1 equals x. So this in turn, x equals e. So now we check if e, which is the critical point, is a relative maximum or a minimum by plugging values of each side into the equation. So a value to the left of e would be 1. So we plug this into the derivative, f of 1. When we solve, it's 1 minus the natural log of 1 over 1 squared, which will equal 1 over 1 equals 1, which is a positive value. Now we plug in a value to the right of e, which is e squared. So the derivative of f of e squared equals 1 minus the natural log of e squared over e squared squared. And we did this to find slope, so the answer is negative 1 over e to the fourth. And this is negative. So our critical point, x equals e, is a relative maximum because it goes from positive to negative. This is the justification for the answer. The critical point, e, is a relative max because if x is greater than 0, then derivative of f of x is greater than 0. Oh, I'm sorry. If x is less than 0, then derivative of f of x is greater than 0. And if x is greater than 0, then the derivative of f of x is less than 0. So since as the critical point x equals e, since it goes from positive to negative, x is a relative max. Now for C. It says, the graph of the function f has exactly one point of inflection. Find the x-coordinate of this point. To find the point of inflection, we have to find the derivative of the derivative. So the derivative is f of x equals 1 minus the natural log of x over x squared. So to find the derivative of the derivative, which is the second derivative, the second derivative of f of x equals, we will do low d high minus high d low, which is the quotient rule. So it will be the bottom x squared times the derivative of the top, which is negative 1 over x, minus the top 1 minus the natural log of x times the derivative of the bottom, 2x, over x squared squared. And we set this equal to 0. Now, if we set the bottom x to the 4 equal to 0, x would equal 0, which again does not satisfy the interval x is greater than 0. So we ignore this. So we set the top equal to 0. So it would be negative x minus, we're going to simplify the top. So it would be negative x minus 2x times 1 minus the natural log of x equals 0. To further simplify, it would be negative x times 1 plus 2 times 1 minus the natural log of x equals 0. Further simplify again, negative x times 3 minus 2 of natural log of x equals 0. So we ignore this negative x because again, if we set it equal to 0, it will not be in the interval of x is greater than 0. So we've set 3 minus 2, the natural log of x equal to 0. The natural log of x will equal 3 over 2. So x will equal e to the 3 over 2. And this is our critical point. Or our point of inflection, I'm sorry. Now, for letter D, it says, find the limit as x approaches 0 from the positive of f of x. So create a barrier. Okay, so the limit as x approaches 0 from the positive of f of x will be the limit as x approaches 0 from the positive of the natural log of x over x. So if we let y equal 1 over x, then as x approaches 0 from the positive, y will approach infinity. Because if we set x as 0.01 or 0.001, it will be 1 over 0.01 or 1 over 0.001. These numbers will be they will reach infinity. So if we let y equal 1 over x, as x approaches 0 from the positive, y will approach infinity. So if the limit as x approaches 0 from the positive of the natural log of x over x equals the limit as y approaches infinity of the natural log of 1 over y over 1 over y. So the limit of y as y approaches infinity equals y, the natural log of y net to the negative 1, because we took the natural log of y from the bottom. So which equals the limit as y approaches infinity, negative y times the natural log of y equals negative infinity. And that is all.